let's think about the logistics of a massive live broadcast for a second. You are at a concert or maybe watching a major sporting event, and you see the exact same video feed on, I don't know, 10 different monitors.
Right. Perfectly synced.
Yeah, perfectly synced, artifact-free.
Yeah.
But you probably rarely stop to think about the actual hardware keeping that signal from just turning into a digital mess.
Which is exactly how it should be. I mean, if the gear is doing its job, it is completely invisible to you.
Exactly. But today, we're looking at the piece of kit responsible for making that happen. Welcome to our deep dive into the Kramer VM-4UX.
It is a fascinating little box.
On paper, it's called a 1.44K 12G SDI DA. That is a lot of acronyms for a tiny aluminum box. So what is our actual mission here? What does this thing do?
Well, at its simplest level, it is a distributor. The 1.4 part just means it takes one video input.
Like your main camera feed.
Yeah, exactly. And it creates 4 identical outputs.
Yeah. Okay, so essentially it's a splitter. But playing devil's advocate here, why can't you just go to a big box electronics store, buy a cheap $50 splitter, and call it a day?
You could try, but it would choke almost immediately. This is where that 12G spec becomes so critical. We are talking about 12 gigabits per second of data throughput.
That is massive bandwidth.
It has to be. That capacity is what allows this box to handle uncompressed 4K video at 60 Hz. And crucially, it supports 4.2.2 resolution.
Let's pause there for a second. 4.2.2. You see that on spec sheets all the time. Does that actually matter for the viewer, or is it just technical jargon?
Oh, it matters immensely for color fidelity.
Right.
A lot of cheaper consumer gear uses 4.2.0, which basically throws away half the color information just to save bandwidth.
Wow.
Yeah, 4.2.2 keeps that color data intact. If you are broadcasting professional video, you absolutely cannot afford to lose that data before it even hits the screen.
Okay, so it is fast and it keeps the color accurate. But here's the catch with high speed. Usually the faster a signal is, the harder it is to push over a long wire.
Exactly. A 12G signal is incredibly fragile. As it travels down a copper cable, it degrades much faster than a standard definition signal would. And that is why the VM-4UX isn't just a passive splitter, it is a distribution amplifier.
I saw the term equalization and reclocking in the notes. Is reclocking just fancy marketing speak for, boosting the volume on the signal?
No, it is much more sophisticated than just turning up the game.
Oh, really?
Yeah, think of the signal getting fuzzy or distorted as it travels. Reclocking means the device actually analyzes the incoming data, reconstructs the timing of the digital pulses, and sends out a fresh, clean signal.
It is like a repeater.
Exactly like a repeater, auto-adapting to the rate and cleaning it up.
Which explains the range specs, because I was looking at the distance capabilities. Sending a full, heavy 12G 4K signal 80 meters.
Which is over 260 feet.
Over copper. That's assuming you use those high-quality Kramer coaxial cables, of course.
Yes, and if you drop down to standard definition, it can push that signal nearly 1,000 feet, 300 meters.
That is wild.
Oh! But that reach is physically impossible without that active equalization and reclocking.
Let's talk about the hardware itself for a minute. In a broadcast truck or a temporary setup, gear takes a beating. I noticed the specs mention reliable wire connectivity with locking BNC connectors.
That is a standard for the industry, but it is vital. In a chaotic environment like a Super Bowl sideline, people are going to trip over cables.
Right.
With a locking BNC, the cable might snap if you pull it hard enough, but it won't accidentally pop out of the port and kill the feed.
Total nightmare scenario avoided. Another thing that stood out to me was the Digitools enclosure. It is fanless. I assume that is to keep it silent for studio work.
Silence is part of it, sure, but for me the bigger factor is reliability.
Because fans break.
Fans have moving parts, they fail. And worse, they suck in dust and debris. If you mount this little 12-centimeter box in a dusty venue truss, a fanless convection design means zero maintenance. It just works.
And runs cool. And if it doesn't work, I noticed there are LED indicators on the front that show the transmitted data rate.
Which is a huge time saver for troubleshooting. You can look at the box and instantly know if you are receiving 12G or if the signal dropped.
It isolates the problem immediately.
Exactly.
So to wrap this up, we are looking at a unit that sells for around $672. It is discounted from $840 actually.
Which might sound pricey for a splitter.
But I guess it is incredibly cheap for an insurance policy against your screens going black.
Precisely. It bridges the gap between the camera and 4 different destinations, ensuring the signal is pristine.
It effectively solves the distance problem for 4K. But before we close out this deep dive, I have a thought for you to mull over.
Go for it.
We are pushing the absolute physical limits of what copper wire can do with 12G SDI. If we need a dedicated aluminum box and all this processing just to move 4K 80 meters, what happens when 8K becomes the standard?
That is the big question. We might finally hit the wall where copper just cannot keep up.
Right, and the entire industry has to completely abandon it for fiber optics.
A massive infrastructure overhaul waiting in the wings.
Something to think about. Thanks for joining us on this deep dive.